Hi, everyone. I'm Aaron Blankstein. I'm on the core engineering team at Blockstack, where we are building a network for decentralized applications, or dApps. So today, I want to talk to you a little bit about how we got to the place where we're at on the internet, where we think the internet is going, and the solutions that we're building at Blockstack. So I'm going to start with a very high-level overview of web technology and how it saw consumer adoption. So if we think back to the mid-90s or early 2000s, there was a lot of excitement about the web. We call this period, looking back, Web 1.0. This was when people first started using applications on the internet. Things like e-commerce sites went live, rudimentary social networks were live, people were interacting with very simple blogging platforms and messaging systems. People were very excited at this point in time, but there still wasn't the sort of ubiquitous usage of web technologies that we see today. And then sometime in the mid-2000s, we transitioned to what we now call Web 2.0. So the big thing that happened there was the advent of cloud computing. So cloud computing was a buzzword that meant, still means many different things to many different people. So for people that were building applications on the internet, they could use other people's platforms like AWS or Azure to get their applications out to users much more simply than they could in the past, right? So in a Web 1.0 world, if you wanted to launch a new e-commerce website, you would have to buy hardware, you would have to run a data center for yourself. And then with cloud computing, you could roll these things out much more easily by just spinning up virtual machines on AWS. For users, cloud computing meant things like software as a service, where instead of running, say, software on all the machines of the computers in your business, you would contract out to somebody like Salesforce or Google, and then you would actually be putting all of your data, putting all of your computation into software running on their servers, and you get some improvements in the user experience from that, right? So there were some benefits there, you were more easily able to share documents with your friends, other coworkers, things like that. You could also do more sophisticated analysis than your desktop or your laptop was capable of doing. But you also were turning over ownership and control of your data to a third party. And so this is leading to a desire to see what's coming next. So at Blockstack, we'd argue what's coming next is decentralized computing. So before I talk about exactly what we think decentralized computing is going to look like, I want to talk a little bit more about the history of the internet and why we think decentralized computing is next. So the way we see it is that decentralized computing is the next swing of a pendulum that's been swinging in computing for decades. So if we look even further back than the advent of the internet, look at computing in the 70s, 80s, they used a paradigm that revolved around mainframes. So in order to do sophisticated programming, sophisticated data analysis, maybe we wouldn't call it so sophisticated now, but at the time it was pretty sophisticated. You would rent time on a mainframe, which was this big piece of iron that cost more money than most organizations wanted to spend on a computer. All the data, all the computation would actually live on that machine, and you would interact with it through a dumb terminal. And this dumb terminal didn't do any computation itself. It didn't store any data. Perhaps you were able to get a printout or something like that. But really, you were renting time on somebody else's machine. And then in the late 80s, early 90s, we went through the PC revolution. And when you tease apart that acronym, PC, it meant personal computing, which is interesting sort of looking back on it, because even at the time, people understood that the data that you were putting into these machines was personal in nature. So if it was essential to your company, that's like data you want to maintain ownership over, or if it's messaging with your friends, like that's very personal and intimate data. And then the pendulum swung back to cloud computing, where the setup started to look a lot more like the mainframes of the past, where all of the data, all of the computation is being done on somebody else's machine, and they actually maintain ownership of that. However, users did get some benefits from this. Social networks became more sophisticated. It became easier to share and collaborate on projects. And so there was a little bit of a consumer win. And now I think we're seeing a higher demand for user control over their data, user control over their privacy, and user control over the way that we interact on the web, because it's such a fundamental part of our lives. Okay. So what does decentralized computing actually look like? Is it just returning to the PC paradigm that we had before? I would argue that no, it's a little bit more complicated than that, because if we think back to how the web worked in the 90s, it was pretty rudimentary. And as users, we've become accustomed to a lot of the nice features that we got during the cloud computing age. Things like seamless collaboration, social networks, seamless messaging between users. All of that's really great, and I would argue that we shouldn't try to put that genie back in the bottle. So when we talk about decentralized computing, we're talking about two users being able to interact with each other seamlessly in the ways that they're accustomed to, but there's no central party that's governing who is allowed to interact with who, governing how they're allowed to interact, or being able to extract value from their communication, right? So if you think about how social networks work today, like Twitter or Facebook, these are like centralized systems where all of the data flows through some central party, and they can do some analysis, they can do advertising, and they can extract all of the value out of the network. And we can see all the time how stuff like that can go wrong. Okay, so at Blockstack, we're trying to build decentralized application platform, and it's really like a reimagining of the internet, and we would call it a new internet. That's the vision, and a lot of people have that vision, and it can be a little bit wishy-washy. So I want to actually talk about the implementation of that vision, which should fill in some of the details for everyone. So at Blockstack, we looked at the traditional internet stack. So traditionally, you can break up the technologies on the internet into 4 layers: the link layer, the network layer, transport layer, and then the application layer. At Blockstack, we feel that the lower layers here, these 3 lower layers, they work pretty well. They're pretty amenable to decentralization. You can use these technologies to talk directly to other people's laptops, other people's phones, things like that. There's certainly things that can be done there to make them more decentralized, like mesh networking or something like that. But really, we identify the problem as occurring in the application layer. So the application layer of the internet today has some like fundamental technologies, things like the domain name system, DNS, or PKIs, like certificate authorities. These are fundamental to the way that we interact with the internet today, and they're totally centralized. But on top of that, there's applications like social networks, document suites, things like that, that also live in the application layer, and those are also highly centralized, and they cause a lot of the problems that we see today. So at Blockstack, we're trying to re-decentralize that application layer. So when we actually dive into the architecture of our network, we see yet another layered system. And the reason that we use a layered approach is because at the base layer, we have a blockchain, but we don't want to use the blockchain for everything on the network, because blockchains, they require consensus among large numbers of people, so they're slower, they can't handle as much data, and they're more expensive than you would want to use for just like every tweet that you write. So we built this layered system where we have a naming system at the bottom, the naming system governs like domain names, usernames, application names, things like that. And it does a really good job there because blockchains are very good at governing ownership rights. So in this case, it's governing the ownership of names in the system. Names in our system correspond to routing data. And that routing data we store in a peer network that every node that joins the network is able to obtain an entire copy of. And then using that routing information, we're able to associate usernames, domain names, and applications with a particular storage location. So a user can associate their applications with storage that they pick. And this could be storage on like traditional cloud providers like AWS or Azure, or it could be a server that they run themselves if they so choose. So this is a fairly complex architecture for developers to reason about or for developers to just use directly. So we provide a developer tooling layer, an API, which masks a lot of this complexity and just exposes user identities as an authentication system, user storage as a storage layer, and access to a token system through developer tooling so that developers are able to write simple applications just like they would if they were using something like Firebase or Google Cloud Compute. And once they've built those applications, they actually function in a totally decentralized way. So I can pull one of these applications down onto my computer and interact with other users without any sort of central authority. For actual users of the system, they interact with it through the Blockstack browser, which is software we provide. You can find it today. If you go to blockstack.org, you can download the browser, or you can use like a web version of it. And this browser allows users to create their own usernames, register names, associate those names with storage that they control, and then also explore the applications that are already built, already usable, and authenticate with those. If you explore this today, you can see there's a number of applications that are already working and that we're pretty proud community members have built. So one or two in particular, so like one is Graphite, which is like a sort of replacement for like Google Docs suite where you're able to collaborate on a document or spreadsheet, share it with other people, and it's really great because it's totally decentralized. We have a messaging system which supports like end-to-end encrypted communication between two users. We have a cryptocurrency portfolio management app which allows you to manage and look at like what crypto holdings you have without storing that data on some third party's server. And we also have a podcasting platform that some community members have been building. There's a lot of excitement right now in the developer community around Blockstack. We're hosting meetups and hackathons really all over the world, 31 different cities, thousands of members, and it's growing all the time. So it's been a really exciting time to work on this platform because so many people have started building apps on it. Yeah, so if you want to find out more, check out blockstack.org. Our software is available for use today. We have developer tools that people can check out. We have some previews of different SDKs for mobile platforms. Yeah, so check it out. And thank you, everyone, for listening to me today.